So for ease of calculation, we're going to assume that the arc length deflects the spring. We're going to assume that it's all at a right angle. And we're going to assume that delta r is given by this radius, which I wrote down as 3.5 millimeters. And then pi minus theta, this must be in radians. You cannot use degrees. You have to use radians. So we are going to assume that the arc length movement is proportional to this radius r and this angular deflection. So what do we know? We know that when theta is 180 degrees, which is 180 times pi over 180 to get it into radians, my delta r equals 0. My delta r equals 0. And I measured the distance x to be 1/2 inch. Then we also know that theta, when theta is around 150 degrees, and these are just approximate calculations. When theta is 150 degrees, I need to put this into radians, x equaled 0.572 inches, and then that meant delta r equals that 0.572 minus 0.5, so I have 0.072 inches of deflection. So delta r has a change of 0.072 inches when theta has a change of 30 degrees. This is what I know. Next, I have to think about my total stretch. So if I think about my total stretch delta x was 0.5 inches minus 0.16, where that was my home length of the spring, and I get 0.34 inches. What I mean by that is I had to take this thing and stretch it and place it into the camera. So that spring actually was stretched to fit inside of this camera so that they actually have a load or a force on this shutter holding this shutter closed. And then for the other case, and I had delta x is 0.572 inches minus the 0.16, which is 0.412 inches. So when this spring is at 150 degrees, when this shutter is at 150 degrees, the spring is being stretched a total of 0.412 inches. That's the total deflection. And so let me reiterate, the 0.16 inches was the home length of the spring. And you actually had to pull the spring to 0.34 inches to get it in the camera. Okay, so I'm reiterating that there is a holding force when the shutter is closed. Obviously, when the camera is in your pocket and you shake it around, you don't want the shutter to open and close and ruin your picture. So you need a holding force to hold that closed. So let's think about this now. So now we're going to have delta x is equal to delta r, my deflection, due to the arc length, plus this 0.5 inches, which is the length of the spring when I put it in there, minus the home position, 0.16. So my delta x is delta r plus this 0.34 inches. Now let's substitute in for delta r. So now delta x is equal to r pi minus theta plus this 0.34 inches. And we can do some checks here. We can do some checks. When theta equals 180 degrees, what is delta x? I have delta x equals r times pi minus 180, and I have to put it into radians, plus 0.34. So delta x is 0.34 inches, which is what I wanted. And then I had a delta x equals r times pi minus, I had 150 degrees, or pi over 180. And my r was 3.5 millimeters. And I had to add 0.34 there. So now my delta x equals 3.5 millimeters times for every 1 centimeter. I get 10 millimeters. 1 inch is 2.54 centimeters. I have a pi minus 150 pi over 180 plus 0.34. And I get 0.072 plus 0.34 equals 0.412 inches. So I've got a good equation. I've got an equation that says delta x equals r pi minus theta plus 0.34.
Stop there.
Okay.